Photovoltaic cells are devices that convert sun radiation into electricity. Photovoltaic cell is like a sandwich. You have two collecting electrodes that are collecting the charges. In between, photoactive material that has possibility to absorb the sun radiation. Our contribution to the development of photovoltaic cells is development of special photoactive materials, usually a semiconductor. Semiconductors have two very important properties. One, it should conduct electricity, as its name. Second, it must absorb sun radiation, and in this process, convert the sun energy into charges. So we develop very special semiconducting materials in the nanoscale. They are very small nanoparticles, and inside this sandwich we spread them as a condensed film. What is very special about these very small nanoparticles is they have extremely good absorption properties. Therefore, they can absorb light very well. Now, depending on their size, we can change the range of their absorption. For example, if they are slightly larger, they will absorb the light in the infrared. If they're a little bit smaller, they will absorb the light in the visible, and also some into the UV. So we can manipulate the size of these nanoparticles as well as their composition, what kind of atoms they are containing, and we can change the range of their absorption.
Our collaboration with Professor Efrat Lifshitz from the chemistry department is concerned with extending the coverage of the solar cells, where normal solar cell would be really mainly active in the visible. A little bit beyond that, we can extend it to really the near infrared and to the medium infrared, and this way capture a lot more light and produce more energy. The devices are micron scale, so we're not trying to make nanoscale devices. We're trying to use nanoscale understanding and capabilities to produce macro scale devices, and through the nano we simply improve their properties and performance. In Israel, when you see solar panels, many of them are really heating water for getting the shower in the middle of the night nice and warm, but the other types of panels you could see would be made of mainly silicon. Instead of the silicon and hard materials-based solar cells, we're trying to develop flexible type solar cells. They can be wall-to-wall printed like wallpaper, and you can really spread them on miles and miles of area and get a lot of the sun energy that's really spreading around without being used. So this way you can really lower the cost of making the devices and installing them, and they can be used on rooftops and any other place you could think of.
There is a huge need to increase the consumption of solar energy. We have a huge potential, but we are not actually utilizing it. So it's urgent, really, to develop means to be able to utilize this solar energy.
Just like in the nano, where the Technion was playing a leading role in the academia and in the industry, it's going to be the same in energy. And basically, if you want to talk about history, then the microelectronics, which is the foundation of this nanoelectronic, was really laid out the foundation of all the microelectronics in Israel. So really, I think we are on the right track.